students, I welcome all of you all for another video session on HDL program or VHDL program for SR flip-flop. Dear students, we have seen the HDL programming of combinational circuits, right? Like we have programmed or we have written coding for adders, full adders, multiplexers, right? Encoders, decoders. So let us see the HDL programming for sequential circuit. So I have taken the example of your SR flip-flop. Okay. So before going to the HDL programming, okay, it is just similar to previous coding which we have put for the combinational circuit. But when it comes to the sequential circuits, we know what are all the elements that comes under the sequential circuits. So once asked in the sequential circuit how to proceed with the program, okay. So we know that SR flip-flop, okay, before going into the coding part, we should know the operation of the SR flip-flop, okay. So you know that SR flip-flop has inputs. So S is my input, so clock, and R is my input, and I'll have the output Q and Q bar, okay. So these are my outputs and these are my inputs, okay. So SR flip-flop is exactly what? So SR flip-flop is an electronic equipment, or it is a component which is used to store a 0 and a 1, okay. So we can give a positive or the negative clock to retrieve the data from the device, okay. So we already know the main operation of the SR flip-flop. So, and also coming to the truth table, we are quite familiar with the truth table. So you have SR, Q and Q bar, right? And when the clock is high, so what happens? So let me consider 0 0. For 0 0 there is no change, okay. For all this instant the clock is 1. For the next condition, when S is 0 and R is 1, your Q is 0 and Q bar, the complement is 1, okay. And for the next case, when your S is 1 and R is 0, Q is 1 and Q bar is 0. And for the last case, S is 1 and R is 1, it is said to be as invalid state, okay. So to write any coding, invalid state, this is to write the coding in a VHDL program. We have very well discussed that you have to know the basic operation of a component, okay, or any hardware that we are going to program. So having known, what exactly is the SR flip-flop's operation, we shall write the VHDL program, okay. So let's start with the VHDL program. You have library, IEEE. So use IEEE standard. These are the inbuilt library functions which we are calling. So entity, so the hardware which we are going to code is our SR flip-flop. So within the port, we know that within the ports we'll declare our inputs. So SR is an input and clock is an input. We very well know that. So this I am declaring as an input. Q bar is my output, right? This is my output, standard logic. So I'll close the port declaration. So these are my inbuilt library functions which I am calling to support my coding program, and within the port I am declaring my inputs. So S is my input, R is my input and clock is my input, and Q and Q bar are my output of the SR flip-flop. So now the architecture flip-flop of SR flip-flop is, so let me begin the coding portion, begin process. So within the process I'm supposed to have my inputs S, R and clock, which is very essential for the process to begin. Whenever the device detects the positive edge, then the device will be active, right? So the process is very important. And let me begin. So if clock is 1, if clock is 1 and clock event, then that means, as I told you, whenever the device detects the positive edge, the device will be active. So for the process to begin, if clock is equal to 1 and clock even, then F. So what happens? So we know that we have the 4 conditions, right? So 0, 0, you have Q and Q bar. So you have, for 0, 0, you have no change. For 0, 1, you have 0, 1. For 1, 0, you have a 1, 0. And for 1, 1, it's an invalid state. Okay. So we have to write all these possible conditions. So that is what I am starting with. So when S is equal to 0, my first condition, when S is equal to 0 and R is equal to 1, so then what happens? My Q, that is my output, remains no change. So I'll write it as Q and my Q bar remains the same. So I'll write it as Q bar. Okay. Else if S is, my second condition is 0 and my R is 1. So this condition is over. Now I'm coming to this condition. When S is equal to 0 and R is equal to 1, then my Q, I can write as Q is equal to 0. My Q is equal to 0 and Q bar is not of Q, right? So when my Q is equal to 0, my Q bar is not the complement of 0, right? So Q bar is not of 0. I'm sorry, not of Q. So that ends. Then let me write the following conditions here. Else if, the next condition, when S is equal to 1 and R is equal to 0, then what happens? Q is equal to 1. You can see here, Q is equal to, for my next condition, when S is equal to 1 and R is equal to 0, my Q is equal to 1 and Q bar is 0. So my Q is equal to 1 and Q bar is equal to not of Q, right? It is not of Q here. Then else if, my next condition, when S is equal to 1 and R is equal to 1, then you can see what happens. My Q is invalid state. So invalid state I'll mention like this, and Q bar is also invalid, right? So I'll have to end up all the if cases. Okay. So end if for all the cases that I've opened. This end if is for the clock and this end if is for the process and the last is for the flip-flop. Okay. So this completes my VHDL program for SR flip-flop. So dear students, what exactly is the truth table? Follow the truth table. And we know that what are the basic inputs that a flip-flop needs. So call your inputs in the port, declare your inputs as well as your output and give the name for the flip-flop and start the process. Okay, without your inputs the process cannot begin, and once you begin with the if-else statement, write each and every possible conditions. So what exactly is your truth table? I'm just replicating that, right? So after giving all the 4 conditions, you are ending up your cases. Okay. Hope students you have understood this program, and this is how you can write the program for any flip-flops asked. Maybe it is JK flip-flop, D flip-flop or any flip-flop. The basic logic you have to know is the basic operation of any flip-flop for that matter. Thank you students. You can revert back to me for any doubts. Thank you.